Cool. Hi, everybody. This is top 5 things that you need to know when you go to virtualize your mission-critical SQL servers. And I'm not talking about the run-of-the-mill, tiny little utility servers. I'm talking about 100,000 IOPS, 64 CPU, terabyte of memory VMs. These are the big ones. My name is David Klee. I'm a vExpert and a SQL Server MVP. I do a tremendous amount of SQL Server virtualization, performance tuning, HADR, all over the world. I have a blast with this stuff. I'm a functional DBA and a VM admin, so I have a lot of fun. Okay, SQL Server, you all know this. It is one of the biggest resource hogs you have in your environment today. Guaranteed. Now the question is, why? And what can you do about it? Okay, to step back, from a DBA standpoint, what do they have to work with? All they know is this is the infrastructure that you manage. They have applications, they have their SQL Server instance, they have the databases, and they have the apps that talk to their stuff. All they know is communication goes in, communication comes into their environment, that's where their sphere, their bubble is at. They redirect it, they performance tune it, but this whole black box of the infrastructure is just completely unknown. The hard part is they don't know the nuances of the infrastructure in order to figure out how to tune it properly, and VM admins don't know the nuances with SQL Server to understand why it's a resource hog and what you can actually do about it to work together to tune this thing properly. It gets scary. So what do you have to watch out for? First of all, first and foremost, storage, 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 and storage. There's your top 5. The biggest thing to worry about is not throughput. There's some guys that I know, they love to use a lot of these utilities where it's just raw disk throughput. It doesn't really matter. It's latency, and it's IOPS, in that order. A lot of virtualized environments that I've seen, latency is in the hundreds of milliseconds. That's bad. That's really bad. Latency needs to be below 25 milliseconds, read and write, regardless of the test. You can actually go prove this. There's a fantastic utility from Microsoft called SQL.io. It's free. All it is a storage benchmarking utility from the command line. The beauty of it is it has nothing to do with SQL Server. It was just written by the SQL Server team, so of course they have to put SQL in the name. But it's a command line utility. You download it here for free. You can run different permutations of read and write tests, random and sequential tests, and change up the intensity and the thread count of the workers. So you can essentially ramp up your test by test type. There's another utility here called SQL.io Batch from Niels Grove Rasmussen. It's a fantastic little PowerShell wrapper for it, and all it does is automate all these different permutations. The cool thing is you just take that output as a CSV file and graph it, and look at what you get. You get a chart that says exactly what your storage, as presented to the VM, is truly capable of performing at, by throughput, by latency, and by IOPS. It is awesome. You catch the weirdest things when it comes to SQL Server. For example, the dip in the sequential write performance there was happening when they were doing a SQL Server backup onto the storage. They were actually filling up the write cache on the SAN so heavily that was actually having to suspend inbound I/O to flush the disk. The more databases they backed up at the same time, the worse it got. This test took 45 minutes total. Picture says 1,000 words. Biggest thing you can do, and I hate to use the phrase throw more RAM at it. Memory in SQL Server translates to a read cache. The more memory you have, the less read I/O you're going to have, period. It does help, to a point. Fastest possible interconnects, most possible interconnects, any kind of multipathing that you have, be it network adapters, be it storage, be it HBAs, PowerPath VE, anything you've got to use what you have available to you. Block size alignment with SANs is another really big one, especially today with flash vendors. I found that a lot of flash vendors have published guides for block sizes for SQL servers. A lot of people don't follow it, and you get block size misalignment between SQL Server, Windows, VMware, and the storage. And it can contribute to a 30 to 50% performance improvement hit on the SQL Server itself. HBA queue settings, queue depth, all of that directly apply. Every vendor out there has got a guide for how to go through and configure the SAN for SQL Server. All of those things still apply when you virtualize it. It really works. Biggest thing, Just improve the performance somehow. Better disk configuration, more SAN cache, more active controllers. You can use SSD caching, so vSphere Flash recache, Pernix data, however you want to do it. Your normal SQL Server is 85% read, 15% write. Guess what? If you buffer half of that, your SAN people are going to love you. And then the other thing, spread out the workload. This is one of those really big sticking points that I have with VM admins all over the place. That's the same set of disks under the covers. Why don't we just have one drive for all the SQL Server objects? Well, look at what's actually under the covers. This is your SQL Server, and this is a simple version of it. Every single one of these can get mapped to different virtual disks because every one of these files has different workload patterns, and if you bundle it all together, it's essentially, it can be 100 terabyte random write workload. That's not good. You split it out by workload characteristic, and you can work with your VM admins on this, and everything gets better. Networking performance is another goofy one. The databases have to be able to talk to the application somehow. How many times do your DBAs never tell you that they may be consuming a terabyte worth of data every night and loading it? Guess what? All that's got to go over the network. Pin the two virtual machines, the source where they're getting all the data from, and the target SQL Server. Pin them to the same physical machine. Guess what? In my little tiny, run-of-the-mill home lab, I got a 15 times performance improvement in network throughput. No code changes. I've used this in production to take a nightly ETL process and shave off 3/4 of the runtime. Easy. Easy to do. You can actually go prove this. iPerf, it's free. Hit my home blog, just davidklee.net. There's directions on there on how to use it. It'll take you longer to download the utility than it will to run and test this. Fastest possible CPU cores at the host level. Not necessarily fastest, or not necessarily the most cores. Most things inside SQL Server are not widely parallelized. Plus, you got CPU scheduling, you got resource contention. If you have a single fastest CPU cores you can get, and maybe not necessarily as wide, there's a good chance you're going to boost performance that way. And again, easy to do. No memory over commitment. I cannot yell this loud enough. Memory over commitment causes ballooning, causes windows to page. SQL Server has to have data in memory before it can use it. Guess what? If that memory is on storage, that is many times slower than memory. It will bury SQL Server performance. No memory over commitment, full memory reservation for production SQL Server VMs, period. One, you guys save that swap file it creates, so you get a lot of SAN space back. But the other thing is, it will guarantee that you will never, ever give back memory. And the funny thing here, memory counters really do lie. These VMs are so huge that it's a target for memory reclamation if there's ballooning. Well, guess what? With this, I loaded 20 gigs of data into SQL Server and then started pounding on it with reporting. I looked over, my active memory counter dropped back down to 0. This active memory counter lies to you. SQL Server uses memory to buffer I/O. This counter measures when that changes. The only way it changes in SQL Server is if it gets flushed out because of memory pressure. That lies. Okay, VM admins, DBAs are going to ask for all the resources they can get, period. CPU, memory, storage. VM admins, CPUs may not matter. Don't give them everything that they want. Make them prove to you that they do need what they're asking for. And forget third-party vendor requirements. I mean, a lot of times, if they've got a 16-core physical machine, they're going to want a 16-core VM. Show them with numbers that it might actually be faster for them to give them half the CPU count. It really does add up. It really, really adds up. The biggest thing that I've got here is called VM right-sizing. Demonstrate, work with the DBAs to say, you need the right amount of CPUs for this job, and it's not a one-time thing. You got to do it now, you got to do it every quarter, because databases can grow, new applications can be introduced into the environment. You turn it on, do the test, it's easy, turn it off. Now, it's not just CPU configuration or count, it's also NUMA. So if I need a 16 CPU VM, what's better? 2 virtual socket by 8 core, 8 virtual socket by 2 core, or 4x4. Well, it all depends on the workload, and it all depends on the infrastructure underneath, but it does add up. It does matter. We did that exact test at a customer with a 4x10 UCS environment. We took their workload, simulated it, and we took an open source driver called HammerDB, did the exact same thing. Check it out. That is a 31% performance improvement in SQL Server by setting the configuration of the VM properly to match the workload and to match the infrastructure underneath. vNuma matters. It matters greatly. It took longer to put this slide together than it did to do these tests. Easy to do. Work with them. Same workload, same configuration. Match the stuff underneath. Tune it. They will be your best friend if you show them a 31% performance improvement in less than an hour. I promise you, they're going to love you. Biggest thing here, it's not the tech side. Organizations have silos all over the place. DBA, storage, application development, SAN, networking, security. Virtualization bridges all of that, but now you know the DBAs are amongst the last holdouts to virtualization, especially with their big environment. So what are you going to do? Education. Involve them with the design of the VMs that are powering the business. Give them read-only access to vCenter. I kid you, I'm not joking. Give them read-only access to vCenter so they can see the performance stats of their VMs from your perspective. Give them access to see the characteristics of the host. Educate them so they know what they're looking at, because a lot of these guys don't understand what's really under the covers in infrastructure. But just a little bit of education goes a long way. Tear down the walls. Open up the environment a little bit, and I guarantee you they will stop hating you. They will come to you with good constructive requests at that point instead of blaming you for every tiny performance hit that they may or may not actually have. Are there any questions? Awesome. Thank you all for coming. If you do have any other questions, I'll be right over here afterwards. Come on over.